Alright guys, today we're going to be looking at lesson 13.2 and we're going to choose between linear and exponential models. So remember, linear is a straight line and exponential grows or decreases at an exponential rate. Alright, so let's start with task 1. Compare linear and exponential relationships. Two venues are possible meeting places for a yearly convention. Each venue projects a different pattern for the expected attendance at the yearly convention for an 8-year period as shown. Alright, so you can see venue 1, it has time from 0 to 7 years and it has attendance 2,500 up to 3,550. Venue 2 goes from 0 to 7 years and starts at 1,100 attendees and goes up to 2,692. Alright, so it says choose the correct statements about changes in the patterns. Select all that apply. Alright, so the first one says venue 1 projects a common difference of attendees from year to year. So venue 1, let's look at the difference here. I have to blow this up because my eyes are not that good. Alright, so from year 1, or year 0, would be the first year to the next year. 2,500 to 2,600 is 150. So that's going to be 150. And from 2,650 to 28 is also 150. 28 to here is 150. 2,950 to that is 150. So you can see that it is increasing at a common rate. 250 to 400 is 150. And 34 to 3,550 is 150. So each one of those did increase by a common number, a common difference of 150. So for the first statement, venue 1 projects a common difference of attendees from year to year. That would be true. And venue 2 projects a common difference of attendees from year to year. So let's look at that. So it goes from 1,100 to 250. So that would be 150. From 250 to 420, that would be 170. So that is not a common difference. It goes from 150 to 170. We don't even have to check any more beyond that. So number 2 is not true. And then it says venue 1 has a linear rate of change. That is constant change from Y per unit change in X. And that would be true because if we have a constant value, we can look at these and it's going to be linear. This means the average rate of change would be the same. So if I do Y minus Y over X minus X, if I do any Y minus Y over X minus X, we're going to get that difference of 150. So that one would be true. That's your average rate of change. That's Y2 minus Y1 over X2 minus X1. And then the next one says venue 2 has a linear rate of change that is a constant change per unit. Alright, venue 2 was not a constant change. Remember, it's not linear because this one went up by 150, this one went up by 170, this one's going to go up by even more, and this one's even more. And so it's not a constant change. So there's not a constant change in venue 2. Alright, so venue 1 projects a fixed percent change. That is not true. Venue 2 projects a fixed change or percent change of attendees from year to year. So could we find a percent change? So that means this one could be exponential. That is probably true. So let's take a look at that real quick and see if that makes sense. So just like from the last section, you learned how to enter these in your calculator. So I'm going to clear out my table, second plus 4, enter, and then go to stat. And I'm going to do each of these. Alright, so I'm going to do 1,100, 1,250, 1420, 1614, 1834, 2084, 2369, and 2692. Alright, so hopefully I got these correct. And then I'm going to go Stat, Calculate, and I'm doing exponential regression. Because I don't think it's linear, because linear would have had a constant rate of change, and it did not. So let's see if this has a percent change. And it does. So remember, a times b to the x power is your exponential function, and a is your y-intercept, and b is 1 plus or minus your interest rate, or your rate of change. So this would be about 13.6% change. So that means this has a fixed percent of change. And that is all for the first question. All right, graph each set of data. What type of functions does each graph represent? How is the shape of the graph related to whether there is a fixed percent increase or common difference? All right, so the fixed percent increase is going to come from an exponential, and a common difference means it's the same thing between each one, would be linear. All right, select the correct word or phrase to complete each sentence. The shape of the graph of venue 1 should be a straight line because it's linear. The shape of venue 2 is exponential. And when the data follows a blank pattern, there is an approximate common difference between the y values. So when it follows a straight line or a linear pattern, it's going to be a straight line, and there's going to be a common difference. When the data follows an blank, it is a percent increase, so this would be exponential. So when the data follows an exponential curve, there is a common percent increase. And that's just the difference between linear and exponential. All right, so what happens to the increase in attendance from each yearly interval at the venue that projects a fixed percent change of attendees? So that would be venue 2. It says explain. Select the correct word or phrase to complete each sentence. So because it's talking about the one that did a percent change, we know that it's talking about venue 2. That's the one we looked up. Or used our calculator for in order to find this percent change, okay? All right, so the number of attendees grew by an increasing amount each year. The attendees increased by a certain percent, not a common difference, and when you take the same percent of increased number, you get an increasing result. And that's what produces the exponential function. All right, that's all for task 1. If you have any questions, please let me know. Lesson 13.2, task 2. All right, growth of linear and exponential functions. Over equal intervals, linear functions change by equal differences, while exponential functions change by equal factors. Complete the proof that linear functions change by equal differences over equal intervals. All right, so it's saying this is given. We're given x2 minus x1 equals x4 minus x3. Now, we don't know what x is, but whatever it is, we know that this x minus x equals x minus x, basically. So it says f is a linear function of the form f of x equals mx plus b. All right, so this is just your general form in slope-intercept form. This is an 8th grade standard. We have reviewed it some this year, but remember f of x is just function notation. This is the same as y equals mx plus b. M is your slope, b is your y-intercept. So x and f of x are really the two variables here. All right, so it says prove that f of x2 minus f of x1 equals f of x4 minus f of x3. So we've got x2 minus x1 equals x4 minus x3, and we want to prove y minus y equals x minus x. Okay, so let's look at the proof. So we've got x2 minus x1 equals x4 minus x3. So this was given information. All right, and what they're going to do is take and multiply both sides by m. So you can see all they did was put what's already here in parentheses, and they're going to multiply both sides of the equation by m. So it says, what property justifies step 2? That would be multiplication property. All right, and then from step 2, they've taken m and they've multiplied by everything inside the parentheses. So this is distributive property. So number 3 would be distributive property. What property justifies step 3? Okay, and again, distributive property just multiplies that out. All right, from step 3, okay, they're going to go down, and it's got m times x2 plus b, and then we're going to subtract b. So what they're doing in this step is they're adding b to both sides, and they're subtracting b to both sides. Again, it's just manipulating the equation. Right now, these are all variables. So if you add the same thing and you subtract the same thing from an equation, you're not really changing it. You're just kind of manipulating it, rewriting it. So from here, they take this, and these both have a negative sign, and these both have a negative sign. So they're pulling out the negative using distributive property in reverse. So again here, same thing. So for step 5, what property justifies step 5? That again is distributive property. All right, that's all for task 2. If you have any questions, please let me know.